Good morning, students. Today we will continue the topic of chemical properties of alcohol involving the alkyl group as well as the alcoholic group. In our last class, we have discussed the acidic dehydration of alcohol. Right, when it is carried at 443 Kelvin temperature in presence of concentrated H2SO4, alcohol gives the alkene. We get the dehydrated product, that is the alkene. And if it is so that we are having more than one alkene formed, that time the major alkene will be the one according to the Setzer rule, that is which is maximum alkylated. Now today we will discuss the next property which involves both the alkyl group and the hydroxy group, that is oxidation. Now student, in oxidation of alcohol, O-H bond and C-H bond, they break up and the formation of CO bond occurs. So here the formation of CO bond will take place and here these bonds will be broken down. Right. So we will discuss first for the primary alcohol. So if we take student RCH2OH, this is the primary alcohol, and if its oxidation is carried with the regular oxidizing agent like K2Cr acidified, potassium dichromate, or we can use the alkaline KNO4, right? That time, this primary alcohol student, it will be oxidized to RCHO. The aldehyde which is formed student will have the same number of carbon atom as is present in the alcohol, right? The reaction student will not stop here only. It will further undergo, aldehyde will further undergo oxidation and carboxylic acid will be formed and it again have the same number of carbon atoms as is present in the alcohol and the aldehydes which are the earlier product. Now student, if we want to get only the aldehyde, right? We don't want the further oxidation of primary alcohol. For that case, we will use chromium trioxide or we can use PCC, right? Either of these two we will take, either CrO3 or PCC. The reaction is going to stop at aldehyde. Now, what is PCC student? It is pyridinium chlorochromate. It is pyridinium chlorochromate. Right? Now, next, if we use student secondary alcohol, if we have secondary alcohol, that time on oxidation with the oxidizing agent, we will get a ketone formed. Right? A ketone is formed. And if this ketone will further undergo change and it will change into students to carboxylic acid. We will get a mixture of carboxylic acid formed here. Now let's take here the example of CH3CH. This is student the secondary alcohol, right? So here we have methyl ethanol. Right here we have got two carbon atom and at the first carbon atom we have got the methyl group attached. So it on further first oxidation will give us CH3, C double bond O, CH3. Right, water is getting removed from here. Then this on further oxidation student will give us CH3COOH plus HCOO H. Right, so we are getting a mixture of carboxylic acid, but if we want to get the reaction, stop that ketone, again student, here we will use any one of these, either chromium trioxide or we can use the ECC. The reaction will stop at the ketone. Right, now students, if the alcohol has the unsaturation at its position carbon chain, let it be this example here CH, this is there, and we have got unsaturation. So in that case, if we use PCC, the oxidation will take place at the carbon atom having the hydroxyl group only. It will give CH3, CH, CH. It will form here CHO. Right? The unsaturation will remain undisturbed. Now student, if we have tertiary alcohol, this is a tertiary alcohol, and if the oxidation is carried here, right? Now students, here you can see that this is not having any alpha hydrogen. Alpha carbon is there, but there is no alpha hydrogen here. So under drastic condition, along with the strong heating, student, there will be formation of an alkene, and alkene will be formed. CH3, CH3. Here it will form an alkene, right? This is an alkene which will form, which will further undergo oxidation to form a mixture of carboxylic acid is going to be formed. We will get a mixture of carboxylic acid here, right? So here, since it is including here the unsaturation, so here students, the different possible the oxidation which can take place here is CH3, CH2, COH. Right. So we are not going to get a particular carboxylic acid here. We will get a mixture of carboxylic acid which further on oxidation will get into carbon dioxide and water form. Right. So here that's why in tertiary alcohol we don't get a particular carboxylic acid. Right. The mixture of carboxylic acid will be obtained on further oxidation. We have the next set of reactions where the alkyl as well as hydroxy group will be involved. That is called dehydrogenation reactions. So here also these reactions are carried at students at 573 Kelvin temperature in presence of copper powder. So here first we will discuss the case of primary alcohol. So here is RCH2OH reaction at 573 Kelvin temperature in presence of copper. So here the hydrogen, removal of hydrogen will take place and we will obtain RCHO and aldehyde will be obtained, RCHO. Right? This is for the primary alcohol. Now if we have secondary alcohol, in this case, same that presence of copper at 573 Kelvin, students we will get a ketone as a product. Right? Now, if we have a tertiary alcohol, if a tertiary alcohol is there, here in presence of copper at 573 Kelvin, students we will get the alkene here. Here there will be removal of water. In other two cases, hydrogen is getting removed, but in case of tertiary alcohol, students will get water removed. Now we can have an example here. Copper at 573 Kelvin temperature So here we will get C. Here from here students, the OH group will get removed. This is CH2. Right? This is about the dehydrogenation of alcohol. Students, next we will discuss the reactions of the chemical properties of phenol. Right? Now you know that phenol, the OH group which is attached to the benzene ring, it is ortho-para directing in nature and it activates the benzene ring for the electrophilic attack. So chemical properties of phenol. So here phenol undergoes electrophilic substitution reaction. It undergoes students electrophilic substitution reaction at ortho and para position. Now let's start with the next first reaction, that is the halogenation. Students, when the phenol reacts with bromine water, it undergoes tri-substitution and bromine gets attached at the ortho and para positions together. So and form 2,4,6 tribromo-phenol, which is a white PPT form. This is also used to distinguish the phenol from alcohol, because alcohol will give no reaction with bromine water, whereas there will be white PPT formation when a phenol reacts with bromine water. Now, next student, if we see the another reaction here, this is phenol. Same, it is again reacting with bromine, but this time student, we are not using a polar solvent, we are using a non-polar solvent, that is carbon disulfide, and temperature is also kept low. It's low temperature. Here student, we will get only mono-substituted product. We will get ortho-bromophenol and para-bromophenol. Right? So here we are getting ortho-bromophenol and this is para-bromophenol. Right. So here you can see that when the bromine is in the aqueous state, we are getting the tri-substitution, and when it is in the non-polar solvent students, we are obtaining the mono-substituted product. Now, what is going to be the reason behind it, student? It is only because that when we use water as a solvent, the phenol gets ionized into phenoxide ion, right? And the phenoxide ion is more reactive toward the substitution than the phenol, right? So why is it so? Because water being polar solvent ionizes phenol to phenoxide ion, which is more reactive toward electrophilic substitution reaction than phenol. Right? Hope Hope so the reason is clear to you and it is visible to water being polar solvent. It ionizes. Student, it is I here. It is ionizes. Water being polar solvent having high dielectric constant. It ionizes phenol to phenoxide ion, which is more reactive toward electrophilic substitution reaction than phenol, and hence it undergoes the tri-substitution as you can see here. Now student, the next property is the electrophilic substitution reaction caused by the nitric acid. So we will give it as nitration of phenol. Now student, here also we get two different products, right? Depending upon whether the nitric acid which we are using is dilute or concentrated. Now just see here, I am writing nitrophenol here. So in the first case it is dilute nitric acid, in the second case it is concentrated nitric acid. So when we are using dilute nitric acid, students, we only get mono substituted product ortho nitrophenol. In the same way we will get here para nitrophenol. Right, and when it is concentrated nitric acid, student, that time we get tri-substituted product, that is 2,4,6 trinitrophenol. So it is 2,4,6 trinitrophenol. Right? This is the product which has been obtained. Student, nowadays the nitration is also carried by first getting the phenol sulfonate. Right, that is, we will first get it converted. This is OH. We will get a reaction done with sulfuric acid. So we will get here OH and SO3H at ortho position. Similarly, we will get OH and SO3H at para position. Right? And then this mixture has been undergone the nitration and we get here right NO2 and NO2. Right. Now this student 2,4,6 trinitrophenol is also known as picric acid. Right. So first the phenol will be sulfonated. It will be treated with sulfuric acid. We will get SO3H group at ortho position and para position, right? And then it will made to undergo nitration and we will obtain, students, 2,4,6 trinitrophenol, which is also known as the picric acid, right? Now students, we will discuss the main reaction or the special reaction which is shown by the phenol. That is when phenol, or we can say the sodium salt of phenol, is treated with or heated with carbon dioxide at 400 Kelvin temperature and 6 to 7 atm pressure, right? This is the first step. Now, okay, now you can also start the student. Start with phenol also. So first you will get the phenol change into phenoxide, sodium phenoxide, or you can begin with sodium phenoxide also. Here it is ONA minus water, is sodium phenoxide. Now this sodium phenoxide is then heated with carbon dioxide at 400 Kelvin temperature and 6 to 7 atmospheric pressure will be there, followed by student acidification. We will obtain student salicylic acid or salicylic acid. Right, this is very important main reaction which generally been asked in the board directly from the name or through the conversion. Right. Second student we have Reimer-Tynan reaction. Student, here the phenol is being reacted with chloroform and aqueous anionic solution. Right. So here the first intermediate student will be formed, CHCl2 here. This is the intermediate which will be formed. Right. Now, after this, it will be again treated with two molecules, or you can say anionic solution. And here it will get, this is CHCl2, and here we will get CHOH whole twice. That is OH group, and here we get 2 NaCl removed. Now students, the CHOH whole twice is actually in this way. CH, this is OH, and this is OH, in this way. So you just get the water removed from here. So if the water gets removed, what is left then? It is ONA at the top, and here we get CH and O. This is left. Now, on acidification with dilute HCl, student, we will get here, this is OH and this is CH. This is known as, student, salicyl dehydration. We obtain salicyl right? Now, next after this, the other reaction which the phenol shows is the oxidation of it. Now, phenol, it is very much subjected to oxidation by air, right? It undergoes oxidation either in presence of chromium trioxide to form para-benzophenol. Another reaction which the phenol undergoes, that is, it can be reduced to the benzene when phenol reacts with zinc dust, or it is heated with it. It will form benzene and zinc oxide is been obtained. Now the next reaction, student, is the coupling reaction which the phenol shows. So when it is being treated with benzene diazonium chloride, it forms para hydroxy azobenzene. This is para hydroxy azobenzene, which again is being used. Yes, it is again being used to be used as a distinguished test between the alcohol and the phenol. Right? As the coupling reaction, a dye is being formed, which is orange colored dye. This is orange in color. Right? So it is a dye. So students, today we have discussed the properties, chemical properties which were left from the alcohol section, and we have today discussed the chemical properties shown by the phenol. So just get it completed, and the next class we will discuss the preparation and the properties of ether.